All right. Hello. So today I'm going to talk about a cool site and an interesting Twitter account that I've been following. When I was studying for my Security Plus exam, I came across this site from my class, and I've been kind of diving into it over the past couple days. So there's this individual malware traffic on Twitter, and what they end up doing is they create these technical blogs and these traffic analysis exercises using PCAPs that you can spend some time in. And a lot of these exercises are some kind of exercise for you to do, right? So you're trying to figure out say why there's a blank keyboard or some other things like that. But one of the other things that you can do with this is you can actually start looking at malware traffic, right? So he actually has packet captures from sees either some threat attack groups or some common attacks that are currently occurring, like for example, a web server with log4j and problematic scanning. Basically, if you want to spend more time with some of the defer stuff, this is a great site. And one of the best parts about it is these tutorials, right? So when I first started looking at this, kind of got it kind of got in over my head. I realized Wireshark has a whole lot than I thought, and basically this individual is a part of Palo Alto, it looks like, and they kind of walk you through some of that. So today we're going to first look at this first tutorial that they have, which is decrypting HTTPS traffic. And then if we have time, we might look at the trick bot infections. It just depends. So really quick, we are using Wireshark. I'm on Kali Linux. This is just the standard Wireshark that's part of it. Some of the things that I've done is I've set up my columns a little bit different. So one of the things that I've learned in playing around with Wireshark is that it actually helps to start kind of modifying some of these columns. So I've added things like the source address and the source port. And you could do that by either editing your columns or going into your view and adding some additional column sets. And that just sort of helps, right? So now instead of some of your standard format, I know the source of where something's coming from. I can see that it's in universal standard time. And then I can see the destination port and other things like that. So what we've done is I've walked through this particular tutorial, decrypting the HTTPS traffic. And we've gotten up to the part where we are just looking at the stream itself for some of the TLS handshake that's occurred over to the site. What this is currently working about is this is an example of the Drydex malware infection. They give sort of an example for that. Drydex is a type of malware that uses Microsoft Word macros in order to try to steal information. So like being key log injectors and being able to do injection traffic. In this exercise, we are looking at the Drydex behavior through a packet capture and trying to figure out what's happening. So a lot of command and control for malware and other things like that go over HTTP or HTTPS messaging. And in this case, some of the problems with HTTPS is that it's encrypted. There are some ways to decrypt it. One of the best ways is that if you need to decrypt traffic and somebody can provide you an encryption key, you can decrypt it, right? So what we've set up is we've gone and grabbed their PCAP. That's each one of these is hosted on a GitHub page. You go download it. If you want to follow along with this, don't do this on your Windows computer. You could infect yourself. Do this on a Linux or a Mac. So now we've sorted it down. And first it asks you had to learn about filters. So Wireshark has the ability to filter pretty much a lot of different network traffic. You can filter down to specifically show me only addresses that are coming over DNS, or filter me specifically to show me something that's coming over to be specific for HTTPS traffic. And that's what we're doing here. We're saying that we only want HTTPS messaging that or is a TLS handshake, right? So when TLS operates, it uses handshakes to exchange keys back and forth to set up your encrypted session. And we don't want anything that's SSDP traffic, right? And they have a wonderful, he has another tutorial that you can follow to get some more understanding of what those filters are. So this PCAP is the Dridex malware traffic on a Windows 10 host. So all of the traffic is HTTPS. And so without the keylog file, we can't see any details other than just the IP, TCP domains and ports. Not super helpful if you're trying to figure out what malware may be actually doing on your environment. So in this tutorial, he's showing us how we can actually load a key file that has the keylog in order to bring it in. So we're going to follow along now that we're at this point. So we're going to go ahead and open our preferences, and that's great. And we're going to go ahead and open our protocols. So, and now it's asking us to scroll down until we find our SSL. And so I'll scroll all the way down. And I may be going fast, but there's a number of network protocols that Wireshark can analyze. I'm sure if it's out there, Wireshark knows about it. So I scrolled past it. I'm not there yet. So STP, snort, TLS. All right, so there's our TLS traffic. And then we need to go ahead and enter the pre-master secret log file name. Some complicated words. What this basically means is that I need the key that has been used to set up your SSL. So if you're a company and you do like some, you have like a firewall or things like that, your network team would be the ones to give you that information. So we're going to go ahead and grab that key file, and we're going to go ahead and enter it. And then we're going to go ahead and click OK. Boom. Great. So this is much, much better. So what this basically has done is this has decrypted the HTTPS request traffic that was going across our wire for this Dridex malware infection. And we're going to kind of put this over here. And let's open this a little bit more. So we can see a couple things here. We see that we're going to some Microsoft domains, and we are seeing that we're going to some Skype domains. And some of this was previously hidden to us, right? So we see here there's a GET request that brings us out to grab some kind of Office request. So this could be either to validate that we have a license key or otherwise. And then we see one for Skype, and then we keep going. So we see that in this same time frame, right, all within a couple of seconds and milliseconds, that this is taking place, that we went from calls out to Microsoft, probably when a Word document was open, to foodgoodforliver.com. So could be that there was a macro or something like that that was opening it. But what's interesting in here is this goods for liver is doing something interesting. It's grabbing this thing called this invest .dll. And that's a dynamic linked library. So this is a Windows executable that is bringing down. And as our blog says, this is actually so there's a GET that's occurring out to foods good for liver. And there it's doing a GET for the DLL, and it's returning it as a post. And that post is actually going to this 10.05711.com. And they say that this is all command and control traffic. All right. How do I actually see that? That's pretty difficult. So what they suggest you do is you first start it. So when we're following streams of network messages in Wireshark or other tools, we need to actually try to group all of those together. So I'm not clicking on the right thing because it says that I should be able to see the HTTP messages. Why is that? Well, because I'm not paying close enough attention, right? So if I want to follow specific messages, I need to pay attention to what the protocol stream says. So these are the SSL messages that are encapsulating the HTTP messages. So we're going to go ahead and follow the HTTP stream. Right. And so now it opens up. And now we got a much better idea of what's happening, sort of. So we see that we actually, it gets all of that. And then it actually puts it all together. And so what we actually need to do is what they're saying is we need to, we can export this malware from the PCAP. So we can actually export it. So because now that we followed it and now we can actually see what's actually happening with the message that it does a get, it brings in the DLL, and then it brings it down. And then there's a bunch of gobbledygook that's going on here. Bunch of messages. We could dig through it. We could see everything that it's saying, but it says there's a much better way. So it's requesting us to do a file, and then we're going to export objects, and then we're going to export it as HTTP. And then we get a number of host names that have been part of this PCAP. So this is all of the hosts that were directly part of it. And so if we scroll back up in our blog, we know that it does an invest, and it says, it seems like after it does the invest, there's a post that goes out to the .com. So given that, it means, as we can see here, that we want to actually find everything from the from the foods.com, good for liver, because we want to get the invest DLL. We don't want the docs PHP because that might be where it's putting the data up to. So let's go ahead and click save, and it's going to save it as an invest 20 DLL. I'll click it again just to verify. And so it's already there. So that's good. We're going to click no, and we're going to go ahead and close that. We're going to go bring our little terminal up here, and we're going to go ahead and open our terminal in this location. And now we're just going to follow along with what it says. So it says that we can use the file command to inspect what's happening. And then it says, we'll do invest DLL. And so we see that it is a P32 executable. So what this means is that this is actually an executable file that's brought in for Windows. Sometimes with Windows Office products, you can actually execute DLLs. I've been in situations where they've said that you actually are to disable all macros for this, I guess, this reason. So now we want to find the hash of this executable. So I'm just following along with what's in the blog, but this is also what some things like CrowdStrike and other tools are doing for you kind of on the fly, right? So 256, invest 20, and we get this hash, right? So we could go grab this hash and we could search for it, but they already have a Google search set up for us. So if we look here, we can see that this says this is Z loader from like any run. That's one. We could also go. You should find the results from at least 2 publicly available sandbox environments. So that's what this one is. So it says this is from an Office document. And it says that this is a banking Trojan. It says that there's a bunch of things that are going on in the DLL. We could use Python or something else, Gedira. Yeah. To extract and open up the DLL and actually see what it's calling. But based on some of those things that we're seeing, they say that this is possibly, a set of malware, right? So that would be the general idea. We would take the hash of what that file is and we would bring it, maybe actually copy the whole hash, but that's kind of the idea, right? So you'll look at that, and then you'll find out. So what we can do is we're going to go back here and we're going to see and try to follow along with what it says that it's doing, right? So the DLL has extracted the DLL is run on the computer and it does some sort of extraction. So we need to follow in the stream to see specifically where it might be requesting that information. So if we go back to Wireshark and we can look at our follow, we see that there's a bunch of junk that's been done for this, unless my VM is completely crashed. That's also a possibility. Okay. Let's go ahead and close that. And we'll go ahead and close that. And let's go to our follow. No? Okay. So what we would want to see in here is we would want to follow through the rest of the text and try to see how it's actually calling it out. So what we would end up seeing is we would see this command and control behavior where it's actually calling out to this 105711 gateway. So let's actually try to pull that back. Oh dear. All right. So I guess I was too hasty and I closed my window. No problem. Let me go ahead and open recent and I'll try to pull that back. Open recent. No, open. And then I'll open you. Food's good for liver. And grab my filter again. Oh. Yeah. And then now that we've got that, we'll want to grab the key, file, edit, preferences, and then we would have to go through the whole thing again, but I'll just go ahead and scroll down to TSL. Okay, TSL, and click OK. All right, cool. So now we've got all of that, and we can go ahead and go to food's good for liver, and let's go ahead and follow, not that stream, we want exactly on the DLL, so we'll follow HTTP. And then if we scroll down, we should see what's happening. So that would be kind of what we would want to do, is we would be trying to investigate and figure out what's going on with this stream. And what we see is if we continue following this, that post that's going back to the 1057, which is probably going to be really far down in the stream, is that 1057 here. So it says we do a client hello, we do a post to the doc. So I bet if we followed this doc and we followed the stream, what we would be seeing is that some messages were being exchanged back and forth for when the malware gets on the system, right? So that's kind of that general idea with that. If we have time, I guess I could go through another one. But yeah, that's kind of what I've been playing around with for this current time.
That was great. We're over time, but
cool.
Potentially we can shelf that for the next one.